Force between two parallel currents. Force between two parallel currents. We are going to find the force. Okay, let's let's see. Here we have two conducting wires, which is infinite in size. Okay, this is conducting wire B. This is conducting wire A, and they are separated by a distance D. Okay, and in them current IB and current IA is flowing. Or two long parallel wires carrying currents exert forces on each other. You will see parallel current will attract each other and anti-parallel current will be repelled by each other. Okay, the figure 39 shows two such wires separated by a distance d and carrying currents IA and IB. Let us analyze the forces on these wires due to each other. We seek first the force on wire B in fig 39 due to the current in wire A. That current, that is the current in wire A, produces a magnetic field vector BA, and it is this magnetic field that actually causes the force we seek. To find the force, then we need the magnitude and direction of the field vector BA at the site of wire B. So at the site of wire, what magnetic field this wire produces due to the current in it. So we will find the direction of that magnetic field at the position of the wire B. Okay, the magnetic field due to the current in wire A. Okay, so how we'll find the direction of that current that magnetic field, we'll see. The magnitude of vector BA at every point of wire B is this. So BA equals to mu naught IA, the current in wire A, okay, upon 2 pi d. D is the perpendicular distance from wire A, okay, to B. So the magnitude of the magnetic field that is produced by the wire A at the position of the wire B is this mu naught IA. So IA is the current in wire A upon 2 pi d, the d, the separation between them. And how can you find the direction of the magnetic field B? You can use this way, okay, like right hand thumb point that right hand thumb towards the direction of IA, and like this it will be in it will be inside the page of the book. So a curled right hand rule tells us that the direction of vector BA at wire B is down. So vector BA is due to IA is into the page. Now that we have the field, we can find the force it produces on wire B. Equation tells us that the force vector BA on a length L of wire B due to the external magnetic field vector BA is vector FBA equals to IB vector L, that is length vector of the wire, cross vector BA, that is the magnetic field due to the wire A, will and then that, so we can have that force vector FBA by this equation. Okay, we can calculate it further by this. So we will have IB LBA sine 90 degree because they are perpendicular to each other. Vector L, that is the length vector of the wire, will be along the wire and towards the direction of the current. So vector L. Okay, and you can find this way, and since vector B is into the page, so you will use your right hand and curl the vector L towards vector B, and the direction of your thumb will point that the direction of the cross product, and which is the direction of the force we are seeking. So the direction of the cross product is the direction of the force we are seeking. So FBA equals to, we will have sine 90 degree equals to 0, and you will put the value of BA from here, and you will have this equation. This is very important, you should remember it. Mu naught L IA IB upon 2 pi d. So FBA equals to mu naught L IA IB upon 2 pi d. So 2 pi d, 2 pi d, mu naught L IA IB upon 2 pi d. So to find the force on a current carrying wire due to a second current carrying wire, first find the field due to the second wire at the side of the first wire, then find the force on the first wire due to that field. So this is very important, you can find it like this is parallel currents, they are attracting each other. If you find the force on this wire also, the force will be towards this, so they will be attracting each other, the wire will attract each other like they are girlfriend boyfriends. If they are parallel, if they are anti-parallel, they have had gone through breakup. How sad. Okay, parallel currents attract boyfriend and girlfriends. Attract. Okay. Oh my goodness. Oh god. Parallel currents attract, and anti-parallel currents repel. Anti-parallel currents repel. You should remember this. Parallel currents attract and anti-parallel currents repel. You can find it out this through all the process we have gone through, but you can remember it. This is important. So there is one more thing. The force acting between currents in parallel wires is the basis for the definition of the ampere, which is one of the 7 SI base units. So, the definition adopted in 1946 is this: the ampere is that constant current which, if maintained in two straight parallel conductors of infinite length of negligible circular section and placed 1 meter apart in vacuum, would produce on each of these conductors a force of magnitude 2 into 10 to the power minus 7 Newton per meter of length. So why are we studying about these fucking things? Because there are applications based on this what we have studied, like a railgun. Okay, a railgun is based on these formulas and whatever we have studied. Now, railgun. A railgun is a device in which a magnetic force can accelerate a projectile to a high speed in a short time. So you can make a gun, railgun,